Okay, so we're looking at congruent polygons, and we need to show that the polygons are congruent by identifying all the corresponding parts. So we need to look at the sides and we need to look at the angles. So let's have a look at the sides first. So if I look at here, I can say AE and RQ. So I can say AE is congruent to RQ. And I'm going to look at AB and RT. And I can say AB is congruent to RT. BC is congruent to TP. And I can look at CD and PS. So CD is congruent to PS. And this one here, ED and QS. So ED is congruent to QS. So all the sides are congruent. So now we're going to check the angles. So angle E is congruent to angle Q. Let's put that on a bigger pen. So angle E is congruent to angle Q. Angle A is congruent to angle R. Angle D is congruent to angle S. Angle B is congruent to angle T. And angle C is congruent to angle P. So the angles are congruent. So we can now form the conclusion to say, as all the corresponding parts are congruent, our polygon, so A, E, D, C, B, must be congruent with R, Q, S, P, T. Okay, we're going to look at an example. So this is corresponding parts of congruent triangles. And we can say CPC, TC in abbreviation. So we're going to look at our triangles. And we're going to see what we can say is congruent. So we're going to use the congruent parts of the congruent triangles. So in the diagram, triangle TRS is congruent to ABC. Find the values of X and Y. Okay, so if we add 14 to both sides, so that is the addition postulate, or addition property, we can write addition property. So I will have 54 is equal to 6y. And I'm going to divide both sides by 6. So this is the division property. So I will have y is 9. And I'm going to rewrite. So this is going to be the symmetric property. And then we can say, so the length ST is congruent with CA, and this is the CPC TC, the corresponding sides. And then if we say x minus 2y, this is equal to 7.5. So by substitution, we are going to substitute in the values. So we just found our value for y, and we can work out x. So x minus 18 is equal to 7.5, and this is simplifying, and I've substituted in here y is equal to 9. So if I add 18 to both sides, I will have 25.5. So that was adding 18, so that addition property. And then I have my answer that x is 25.5 and y is equal to 9. Okay, in this diagram, we have triangle ABC is congruent with triangle HEF. Find the values of x and y. So ABC, so A is going to be congruent with H. So angle A is congruent with angle H. So we can say, by substitution, 35 is equal to 6x plus 8. And I'm going to minus 8 from both sides. So 6x is 27. So if I divide by 6, so we will have x, oops. So if I divide both sides by 6, x will be equal to 4.5. So I know that x is 4.5 and I need to find y. So y says I know as well that because they are congruent, I know that this length is also equal to this length. So I can say that 2y minus 3, actually, let's write it like this. So BC is congruent, so B to C is congruent to F to E. And this is 2y minus 3, and this is congruent to 2.5. So I'm going to make it equal. 2y minus 3 is equal to 2.5. And I'm going to add 3 to both sides. So 2y is equal to 5.5. And if we divide both sides by 2, we will have 2.75. So you have a values, x is equal to 4.5 and y is equal to 2.75. So if we check, we'll substitute 2 times 2.75 minus 3. So we got 2.75 multiplied by 2, minus 3, and that is 2.5, which is equal. So that is correct. And if we substitute in, we have angle 35, and we do 6 times 4.5 plus 8. 6 times 4.5 plus 8 is 35. So we know that is correct. Okay, we're going to look at something called the third angle theorem. And this means if we have two triangles, and we know that this angle is congruent, and we also know that these angles are congruent, then we can say that in a triangle, let's change the colour, then these must also be congruent. So we can say if two angles in a triangle are congruent, then the third angle is also congruent. And this is the reason it is called the third angle theorem.